Okay, question 2, organic. Hopefully we can do these ones. Unfortunately, as usual, 2.1 starts the definition, which you guys need to study, which you're not going to study. But that is 2 marks. So we need to study our definitions. The definition is it's an organic compound that consists of hydrogen and carbon only. And you get 2 or 0. And you need to say only. So it's an organic compound that consists of hydrogen and carbon only. Hydrocarbon, hydro from hydrogen, carbon from carbon. Then, for 2.2.1, they want 2 compounds that are unsaturated hydrocarbons. So this, they just told you about it here, carbon and hydrogen only. So it can't be G, can't be H, can't be F, can't be D, can't be A. So we need to choose 2 that are unsaturated hydrocarbons, and we can only choose between B, C, and E. And we know that unsaturated means that there's a double or triple bond, and you can see here in C, it's "-ine", which means it's a triple bond. And in E, there's this thing, which is a double bond. So for 2.2.1, it should be C and E, and you get 1 mark for both of them. Then for 2.2.2, chain isomers. Chain isomers, if you want an isomer, they need to have the same number of carbons in total. The same number of carbons in total. So that's also maybe going to be a bit tricky. But we don't need to worry about saturated or unsaturated. We don't need to worry about hydrocarbons because it doesn't say hydrocarbons. We just need 2 of these. How many are there? 1, 2, 3, 4, 5, 6, 7, 8. 2 of these 8 things that have exactly the same pieces together. And it is a chain isomer. Chain isomer means that the parent chain length changes. So this here is bute, this is also bute, it's not those 2. They both have 4 carbons in the longest chain. That is not a chain isomer. This one has 1, 2, 3, 4, 5 carbons. This one has 1 and 5, that doesn't help. This one has 1, 2, 3, 4, 5 carbons. So, but this one is not 5 in a row. So, again, it's possibly going to take you longer, but I'm thinking about these 2 because I don't know whether you should know, I don't know whether we've studied this yet, but this is an aldehyde, this is also an aldehyde. Both of these are aldehydes, which is good. They're not a functional isomer. I want a chain isomer. And D has 1, 2, 3, 4, 5 carbons in it. H has 1, 2, 3, 4, 5 carbons in it. So they are both aldehydes with 5 carbons. If you count the H's, you'll see that they have the same number of H's. I know that they will because they're both aldehydes. So the chain isomers are going to be D and H, and you get 2 marks or nothing. So you have to get both of those correct. The reason why 2.2.1 is only 1 mark and 2.2.2 is quite a few is because it would take you longer, probably, to do 2.2.2. A chain isomer has the same carbons, hydrogens, oxygens, but this one here is pentanal. It's 5 carbons in a row. This one here is 1, 2, 3 carbons in a row. This one is 2,2-dimethyl propanal. It's a 3-carbon aldehyde with 2 carbons added on. This is 5 carbons in a row, and it's an aldehyde. So isomers can be a bit tricky. 2.2.3, they want a secondary alcohol. Secondary alcohol, I don't know whether you remember that now. There's a lot of theory we need to know for organic, and the only way we're going to do it is by doing as many examples as possible. A secondary alcohol, you have the carbon that has the hydroxyl attached, and there are 2 other carbons attached to that carbon. So the carbon that has the hydroxyl has 2 carbons attached to it, and that makes it secondary. So they want an alcohol. Here are the 2 alcohols. So if you can just draw them even a little bit. So butanol, 1, 2, 3, 4, and the OH is on number 1. The carbon that the OH is attached to 1 other carbon. It's not that one. Then if we look at butan-2-ol, 1, 2, 3, 4, the second carbon has an OH on it, and the carbon that the OH is attached to 2 other carbons. It's butan-2-ol. It's A. So that answer is A. Sorry, I could just be showing you the memo, but I thought I'd show you where it comes from, because otherwise I'm not sure it helps. So for 2.2.3, the answer is going to be A. If I can move this bloody thing. A, see there? Okay. Then, so 2.2.3. Then, 2.3.1, we really do need to learn quite a lot of language here. We want the structural formula of the functional isomer of compound D. So we've done a chain isomer already. Chain isomer, there's a different number of carbons in the chain. So we had 5 in the one and 3 in the other one. For the example, that was the answer. A functional isomer, there are actually only 2 of them. There's acids and esters. So acids and esters are functional isomers. The one is an acid and the one is an ester. They're 2 different things. And they do 2 different functional groups. The other one is ketones and aldehydes. It's ketones and aldehydes. Those are the only 2 different types of functional isomers. So they want a functional isomer of this guy over here. That thing, D, is an aldehyde. So I must draw a ketone with 5 carbons in a row. I mustn't change the 5 carbons in a row, because then it would also be a chain isomer. They don't want chain isomer, they want functional. So I need to draw a ketone with 5 carbons in a row. And there's going to be 2 different options. You either draw the C double bond O in the middle one, or on the second to last one, or the second one. So either on this one or this one. But this thing, it's the same either way. This one, you don't need to name it, but this one would be pentan 2-one. This one would be pentan 3-one. So they're going to draw that here for you now. Hopefully you can see what they did, because I just drew it for you anyway as well. But I just want you to see what the memos look like. So the functional isomers, it's either ester and acid, or ketone and aldehyde. So here, you see there, they either drew it, so it's 5 carbons in a row, 5 carbons in a row, and it's either on the third one or on the second one. You get a mark for it being a ketone, so you get a mark for putting a double bond O pretty much anywhere, and then you get the other mark for it being 5 carbons in a row. If you had more than one functional group or the wrong functional group, so if you drew an alcohol, you get 0. If you drew an acid, you get 0. If you drew an ester, you get 0. And if you use condensed structural formula, you get a maximum of 1 out of 2, because they asked for structural formula. So just do what they asked for. Then, for 2.3.2, they want the general formula of the homologous series to which group B belongs. So B over here is a hydrocarbon. It only has carbons and hydrogens. And if you can count here quickly, there's 1, 2, 3, 4, 5, 6, 7. There's 7 carbons. There's 7 carbons. If you want to draw it out quickly, it's 1, 2, it does something like this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this is what it looks like. And if I can highlight it for you, hopefully it'll help. So basically, if I can highlight it, these red ones are these 2, which are stuck on. They're stuck on to this blue one, which is that one over there. And then these two, which look a bit weird, are just these two in a row. So B looks like that thing that I just drew there, but you don't need to draw it in order to answer this question. They want the general formula of the homologous series. It's a hydrocarbon, so basically you know it's going to be an alkane, an alkene, or an alkyne. If you can draw it, it would help, but otherwise you just need to be able to count it. So there are 7 carbons, and there are 3, 6, 9, 10, 11, 12, 13, 14, 15, 16 hydrogens. 7 carbons, 6 hydrogens, that's CN, H2N plus 2. That is an alkane. It's an alkane, there's no double or triple bonds. So, the memo which isn't here. Oh goodness, come on Terry. Sorry, let me just carry on with it on this page. There it is. They want the general formula of the homologous series to which compound B belongs. It is an alkane, and the general formula of the alkanes is CnH2n plus 2. Then the next one, they want you to draw this bad boy out. So what happens with these is we start with the surname. We start with the end part, it's pent. So for C, what we start with is we draw 5 carbons in a row. 5 carbons in a row, and on the first one we have a triple bond. There we go. Then on the third one we have an ethyl. So let me just add that in a different color. Third one we have an ethyl. Ethyl is 2 carbons. So that there is the skeleton of what we need. And then in order to get the rest of the marks, you just need to ensure that every carbon has 4 bonds. So this first one needs an extra H. This one already has all of its bonds. It already has 4. This one needs an extra H. This one needs an extra H. Extra H. 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 Oops, I'm not doing this well. H. H. So you must add in all your extra hydrogens. And so that's my ugly little one. But I'll show you their one. It'll probably be nicer. So on the memo, and I'll show you where you get your marks and things. On the memo, see there, the functional group, the triple bond, you get a mark. And then for the rest of it, you get a mark. So you get 2 marks for drawing that. And you start with the surname. You start with the parent chain, which is 5 carbons long with a triple bond. And then you add, on the third one, you add 2 carbons. And then you must make sure that all of your H's are correct, which is always a bit of a pain. Okay, then for 2.4.1, they want you to name E. They want the name for this guy over here. So step 1, we need the longest continuous chain of carbons, and we need it to include the double bond. So if we do that, it's 1, 2, 3, 4, 5, 6. Or alternatively, we can go 1, 2, 3, 4, 5, 6. Either way, it's 6. So I don't know whether you want to redraw it or something, if that would help. But the longest straight chain is 6, so it's hex. And then the stuff that's been added on. So if I say these two have been added on, that is an ethyl group that has been added on. And this thing over here is a double bond. That is an ene. So if I number from this side, 1, 2, 3, 4, 5, 6. Or if I number the other way around, I get 1, 2, 3, 4, 5, 6. The green numbering, the ene is on number 3. Sorry, I should probably write it in green. For the green numbering, the double bond is on number 3, and the ethyl is on number 4 with the green numbering. If I do the red numbering, the ene is on number 3, and the ethyl is also on number 3. The red numbering is lower, and so the red numbering will be the correct answer. So now it's hex 3 ene, and on the third carbon there is an ethyl. 3 ethyl, hex 3 ene. And sorry again, I don't know why I'm rewriting it, because they have it on the memo, but let me just see if I'm right. Okay, 3-ethyl hexaene, 3-ethyl 3-hexene. And the marking, you have to have hexene, you have to have ethyl, and then the numbering and everything else. So it's 3 marks. You get 1 for having an ene, 1 for having an ethyl, and then 1 for everything else. You get 3 marks. Oh, sorry, I must hide that. Okay, so next one, G, same. It's the same process. This is a bit mean to ask you to name 3 of them, but anyway. I think we really enjoyed naming once upon a million years ago. The naming for G, so exactly the same process as we just did. Step 1, the longest continuous chain of carbons. So 1, 2, 3, 4, 5, 6. This is also 6. So the red ones make the longest continuous chain. I don't want to waste your time showing me counting over and over again. I know that that's the longest chain because I've done about a bazillion of these examples before. And the blue stuff has been added on. So now we just need to do the numbering, and it's not just, but we need to do the numbering. We either number 1, number 2, number 3, number 4, number 5, number 6 with the green, or we number with the black, and we do number 1, number 2, number 3, number 4, number 5, number 6. So with the black version, we have hexane, and we have a chloro, 2 chloros. So we have dichloro, which has been added on, and we have 2 methyls that have been added on. So it's dimethyl. This one comes first alphabetically, that one comes second alphabetically. With the green one, it's going to be same. We have hexane, and we have 2 chloros that have been added on. These ones need to be mentioned first alphabetically, and the dimethyl needs to be mentioned second alphabetically. So with the green numbering, the chloros are on number 2 and number 5, and the methyls are on number 3 and number 5. So it's 2, 5, and 3, 5. For the black one, the numbering for the black numbers, the dichloro, it's on number 2 and number 5, which is the same as the other one, and the dimethyl is on number 2 and number 4. So you see how subtle it is. So 2 and 5 and 2 and 5, it doesn't matter, it's both the same, but 2 and 4 is lower than 3 and 5. So we need to use the black numbering. And we start with hexane. So the hexane is just hexane. Then we need to mention the dichloros first. So it's 2,5-dichloro, commas between numbers, and dashes between words and numbers. So numbers and words, dash, numbers and numbers, comma. Then it's 2,4-dimethyl. And it's dimethyl because there's 2 of them. It's dichloro because there's 2 of them. So let's see if I got it right. So 2,5,2,4. So that you get 3 marks for. And let's just see where the marks are. Oh, come on. So if you have a hexane, if you said hexane, you get a mark. If you have dichloro and dimethyl, you get a mark. And then if all your numbers are correct, you get a mark. Okay, so that was G. Then we need to do H. Sorry, I'm going like really fast now, but I mean, anyway, it's 2,2-dimethyl pentanol. No, 2,2-dimethyl propanol. But, sorry, if I do it properly. So again now, what we're going to do is the longest continuous chain of carbons, including the interesting oxygen bit. That is propanol. We do not put a number for it because this is carbon number 1, guaranteed. So that is propanol. We don't say that that's number 1 because it's always number 1. Propanal, be careful to not do ol. Ol is an alcohol, so we have propanal, and what's been added on is 2 methyls. So it's dimethyl propanal, and where have they been added on? This is carbon number 1, so that's carbon number 2. So it's 2,2-dimethyl propanal. You don't really need to say 2,2 because you can't add them anywhere else, but I'd rather we do it properly. So 2,2-dimethyl propanol is what I'm hoping to see here somewhere. There we go. And then I don't know what the note says. See, if you say 1, they're going to penalize you. That's a horrible word, sorry, but you don't need to say 1. You need to know that the 1 is unnecessary. Propanol, it's always on carbon number 1. So it's 2,2-dimethyl propanol, and I'd rather we just add in the 2,2. I'm not sure they're ever going to let you get away with not doing that. Okay, then, do I have the last bit on here? Oh, I do. Great. So now this is going to be a bit of a thing. I don't know whether to leave this here while I do it. Have I lost it? No, haven't lost it. So, compound B is this guy over here. We did him earlier. It was C7H16, if you can remember. And then you add oxygen to it, and you make carbon dioxide and water. We are probably going to be asked one of these in our prelims, and then we're probably going to be asked one of them in our, what's the other thing called? Finals. You might as well learn how to do this, because we're probably going to get asked it. You balance the hydrogen first, then you balance the carbon, then you balance the oxygen, because I said so. If you want to fight me about it, that's fine. But you balance hydrogen first, then carbon, then oxygen. This is the quickest way to do it. Hydrogen, then carbon, then oxygen. And this number has to be even. It has to be even, otherwise you must double it to make it even. And that is how you balance. It's the quickest way you can balance, and you get 3 marks for it, so we might as well get it right. This is 16, so this needs an 8. That is an even number. I do not need to double it. This is a 7, this needs a 7. And now, I do the oxygens. 7 times 2 is 14, plus 8 is 22, so that must be an 11. So there is the quickest way of doing it. Hydrogen first, then carbon, then oxygen, and the number in front of the H2O must be even.